wanted to get a chance to listen in, so just...
Yeah.
Oh, okay.
So this is about FDI. So I'm expected to stand in front of this for a week, and I go, okay, well, what do we have that's written down on this? And Anna Maria smiles and says, it's all in Jason's head and Harry's head. And so I said, I need to get some time with you just to go through the conceptually what this is.
Okay, so the video's for you.
Videos for me and also Michael and Nathan.
Okay,
Yeah.
so it's not
No, it's not going anywhere.
video
No,
that goes on.
no, this is just an easier way of taking notes. So, I mean, as I said, I'll be doing the business builder, so we need to have a script for myself, Shengang and Joris. We're doing a brochure which will look like a version of that or whatever that we can just give out to people, and then there's the Q&A. And it'll be more talking about the technology that you see here as opposed to what Jeff is doing, which is more about, well, what's the business context we put this into.
I understand.
So that was what I wanted to get a bit more of an understanding of what you're thinking about FDI. So where, I understand the high level, this is like a conceptual picture of where we see this technology going 20 years from now or whatever, but not necessarily totally real.
Yeah.
But I want to understand drivers, shortcomings, and then some of the gotchas, because if I will end up talking to knowledgeable people, and I want to make sure I'm not going to make myself a fool by saying, yeah, you can do this, and go, no, for reason X, Y, Z, that's never going to work. So if we start with okay, why FDI, why do you see it going this way? And I guess we've got 25 minutes, so we'll have to go fast on this stuff.
No, but I think, yeah, that's not, we can cover that. I mean, okay. Part of it is the biggest mistake we can make in this is thinking that this is like a hardware story. I mean, people, we tend to sort of go and say we have this and we'll hug that for everything else. If you start at the very bottom, I mean, we're going to be showing a wall of these things.
Yeah.
And then we have BSP sitting over there. And then we have like an HDS sitting over there. And then we have like an OCP sitting over there, right? And you always have to ask these questions like what's similar amongst these things and why? And what's different and why, right? Now then the irony is you sit there and you stare at the wall and you're like, oh, there's an Intel chip. There's a networking chip, and there's DIMMs, and some of them can't store data permanently, and some can.
Yeah.
And then you go over to the BSP and you look and you're like, oh, there's a chip, and there's a networking chip, and there's DIMMs that you can't store stuff on, and there's this. And you go over to HDS, same thing. You go over to OCP, the same thing. So when you think about why that is, was if you go back. Even 10 years ago, it wasn't just an x86 chip. There were MIPS chips, there were SPARC chips, there were power chips, there were all sorts of things. And we continue to have a bit of that diversity now, but it's for like the right reason. So we still have these things where if you're doing something repetitively in software, it makes sense to have hardware do it, right? It's just that, and that's why if you look at one of the big, one of these ironies where we talk about traditional telecom gear here, and you talk about someone like Amazon here, but it's really more of a circle. Amazon is more like a traditional telecom equipment manufacturer than they are like an IT vendor. They have no problem making a custom chip to do something. They have no problem baking it down in the hardware if it's repetitive. And it's just that many things in the telecom space we do are repetitive.
Yeah.
So if like you're just sitting there processing packets, you're just sitting there doing diameter signaling, you're just sort of sitting there doing this, of course it makes sense to put that in a piece of hardware. Because the truth is like software doesn't run in the absence of hardware. Hardware innovation always outpaces software innovation. In the absence of hardware that can do something, you can't write software. I mean, if you're somebody who's messing around with Raspberry Pis at home and doing some interesting things on Raspberry Pis, could you do that if the Raspberry Pi doesn't exist? No. Could a Raspberry Pi existed if a 32-bit ARM chip that was like $8 didn't exist? No. Like, it's got to exist.
Yeah.
And sometimes when we sort of say these things like, software is eating the world and it's all about software and it's software defined and this and that, it's true. It's true. But we always have this activity where we put repetitive things that we do in hardware. And it's a reality, and it always has been, that hardware outpaces software. New hardware capabilities means you can do new things with software. That's a fundamental truth,
Yeah.
regardless of what you do. And if you go back 100 years ago, it's the same damn thing.
Okay.
You know, in the sense, because you can even think, I mean, if you even think of like, you know, the mechanical computer that Alan Turing worked on to do cryptography.
Yeah. Well, yeah.
Right? That was just faster pen and paper. Before that, you'd have to do it with pencil and paper.
Yeah.
Now you do it in this mechanical device, sort of helps you go and do it.
Yeah.
That's sort of all it is, you know, in there. You know, so we have to do this type of thing where we're saying that, you know, largely x86 has won, and there will probably be another thing that's won too. And largely what's won in the other space is that people take ARM and they use it as the core of a system instead of building a custom ASICs or a custom FPGA or something like that. So you sort of have out there in the hardware world, you have x86 and you have ARM-based system on chips. That's what you have. And many switching chips are ARM-based. You know, our own management unit in HDS is ARM-based. But, you know, basically when you stare down at the chip level, you see ARM system on chips and x86 chips in the world. And then you basically see the same type of memory that only comes from 3-4 companies.
Taiwan, yeah.
You know, you're staring at rotating media that is coming from 3 companies. You know, and you're staring at, you know, non-volatile memory that's largely coming from a combination of either the memory and the storage guys. That's sort of what you're staring at.
So at that level, would you say the innovation has run out?
No, because I mean, these are, you know, what it is the innovation there is not run out, you know, but what you do have is you have two things, that the components innovate right now on an exponential curve.
Yeah, but that's like lower power, more transistors.
Take your pick. Whatever you want to decide you're going to do, whether it be unit economics for this, whether you look at CPUs, memory densities, it's an exponential curve of innovation on that, okay? But then when you look at most organizations, do they have an exponential curve in the amount of applications they can handle?
Yeah.
No. Do they have an exponential curve on cost? Yeah, sometimes, you know. And in a lot of ways, when you start thinking about it, is down at the component level, there's like the Moore's law of everything. Everything's innovating on this curve. Yet very few people are taking advantage of that. Because there's all this other stuff between the component and you.
Okay, yeah.
Right? And there's no unified software view of it.
Yeah.
Okay? So when you sort of go another level up, then what we're typically doing is we're taking these chips, memory, networking capabilities, and storage, and we're usually either making network equipment, or compute equipment, or storage equipment. That's what we're making. And you go out there and you say, well, you know, traditionally Ericsson's like a network equipment maker. Dell's traditionally a compute equipment maker. You know, EMC's traditionally a storage equipment maker. And each one of us that makes this equipment optimize the full stack, where we do the natural thing that over time, as you're doing the same repetitive behaviors, you're pushing it down into hardware.
Yeah.
But again, the way that most of us are pushing it down in the hardware is we're pushing it down into an ARM system on chip, or we're pushing it down into some instruction set architecture that's now Intel's made available, but pushing down. And we see this even in the case of like virtual machines and virtual network functions and everything else like that. If Intel didn't do extended page tables in 2009, then VMs wouldn't be fast enough. And we wouldn't be doing them. We'd be taking a 30% hit on memory, a 30% hit on CPU, wouldn't be fast enough. And then if you look at it now, the thing is like, then the usual complaint is, you know, Intel did CPU offload with VTX in 2006, and they did memory offload for this in 2009. but they haven't done network offload and they haven't done CPU offload. So in the network offload space, then all of a sudden you start seeing these smart NICs appear where you have an FPGA on a smart NIC that's now meant to do that offload. And now with things like the Skylake chip coming from Intel, that FPGA is also on the chip. So now that chip can do CPU offload and memory offload and network offload, but it still can't do storage offload. You know, these sorts of things like that.
Yeah.
And so if you think of that, I make storage equipment, I make compute equipment, I make network equipment.
Yeah.
You know, then if you're sitting there and saying, well, I make network equipment and I want to put a lot more compute and storage in it. Well, it turns out that's the most expensive thing to do, is to put more compute and more storage in network equipment, the way it's designed, okay? And then if you sit down and you say, well, I make compute equipment, but now I want to have a network and a storage story. Then you package these things up and you package them up and you end up with a whole hyper-converged world. You know, where you're basically making like a Raspberry Pi that does everything that goes somewhere, right? And that's how those guys have gone. And then if you look at the storage equipment stuff, it becomes a little bit more interesting in that most of the storage equipment vendors, if you will, haven't really innovated this way. But when you go off to the Googles and Amazons and everybody else in the world, they care about the data, not the app and not the network, the data. And so then when you start optimizing everything around the data that you're doing, when it becomes a very data-centric, data-intensive type architecture, then you're essentially designing a data environment where everything having to do with compute and network is a feature of it. So the funny thing, so if you flip this and you say, okay, there's storage equipment, compute equipment, network equipment, they tend to live in silos. And then the compute guys have packaged it up into vBlocks and hyperconverged and this from a packaging effort perspective. But then when you start thinking about it from a data perspective, if you go really data-centric and data-intensive, because now more people, more than just scientists and Google care about data, more people care about data, then what we're going to see is everything's going to shift to this very data-centric, data-intensive type architectures. Now, that's traditionally like scientific computing. And so if you sit around and you say, okay, if I want to build a supercomputer for the purposes of doing a data-centric, data-intensive supercomputer, then the thing that basically always blocks what you can do on that is the interconnect speed and how you think of the interconnect and the complexity of that networking interconnect in it. It's a feature of the system. It's not the point of it, but it is the thing you have to tackle in that, okay? Now, when you start sort of stepping up and stepping back and saying, okay, well now I want to build a system that does all of these things. Okay, there's 3 design centers I could go. I could build network equipment, like a chassis router. We've done this before, by the way. This is what the SSR is. I could build a chassis router and put more shit in it so I can run more apps on it. Very expensive. You know, I can take all these things and package them differently. But other than benefits of packaging, there's an end to that. Or I can design a data environment.
The packaging one would be mechanics, the hyperconverged type route.
So, and you have some simple tests of these types of things. You know, so for example, if you have to move data to do something to it, it's not data centric. If you have to do a lot of work to add a feature to the data environment, it's not data centric. You know, and so, and the thing that not everyone realizes is, you know, somebody like an Amazon Web Services is very data centric. You have a thing like S3, the object store service, and you put an object store in there. And let's say you want to add a feature like deduplication, the idea that if you have the same object, you don't keep the object, right? Okay, well, you know, in the storage equipment world, it took years, meaning like 5 years to really get deduplication in there, another few years to really make sure it was working, and then it doesn't always work for everything. If you're putting your email on it, you're putting your, you know, file stores where you're keeping your PowerPoints and so on like that, it does a very good job with like deduplicating these things. But if you look at how you implement deduplication at Amazon, like they don't have it there. You write a little application, right? Usually in things like Node.js. And when you upload an object to S3, it fires off to the notification service you've uploaded something. It executes the job as a Lambda job, which looks up a checksum in Dynamo. which then fires off to the notification service again to fire off to basically S3 to say, don't store that file.
Yeah.
So an engineer sits around in an afternoon and about 200, 300 lines of JavaScript has implemented a feature on Amazon that took the storage industry 5 years.
Yeah.
That's the experience you get in that data-centric, data-intensive environment. So if you look at, you know, which one of these three design centers do you want to live in?
Yeah.
It's sort of the data-centric. And then the first thing that the data-centric, data-intensive environment always brings you to is what your interconnect is.
Yeah.
And simplifying that, right? And so for us, when we start sitting there and saying, okay, well, you know, the world's going from 1 gig to 10 gig to 25 gig, and we typically have like a, you know, NIC with a, you know, usual sort of electrical chip on it with a copper line in the back, you know, or what we do is we buy these little transceivers that go electrical on one side, optical on the other side. We use an optical cable, but it's an electrical system basically sitting there. But then what you do is you have a card for your network, your NIC, and then you have a storage controller card for your storage. You have a cable for your NIC, you have a cable for your storage. You know, your system processor's got another cable. You know, and then if you want to extend the box, you're taking a physical card and slotting it into a PCIe slot, which is like a slot that slots in. But that's basically the same as another cable that you're plugging in. You know, so you're basically staring at a box and you're like, oh, there's PCI there, which is a protocol that's got an interface like this, and there's IP that's a protocol, it's got an interface like this, there's IPMI, it's a protocol, it's got an interface like this, there's SAS, it's a protocol, it's got an interface like this. But then when you actually decide that you want to simplify that system, then you say, okay, what would it take to have one card that did all these protocols on one cable like that? What would it take to go beyond 25 gig, you know, in there? And the answer is optical. Yeah, so at that point, you're basically going to be building an optical card.
Yeah.
Because you don't, just from a matter of physics, if you want to do 100 gig on electrical, it's 4 by 25.
Yeah.
There's no 100. But an optical is 100. You can make 100 and 200 and 400 and everything else.
Yeah.
The other way to think about it is that we've been doing high-speed optical in the larger metro pops and at the edge and everything else like that, where there's like large-scale traffic's going on. Now, if those things become cheap enough and small enough, which they are now, then you move those into the data center to help with the traffic problem there too. So we sort of have these things that, you know, typically like large, you know, 100 gig, 200 gig carrier Ethernet now becomes a NIC.
Yeah.
Basically. Okay. So now you're sitting there on a much simpler system where you have a board, you have one bus, one card, one cable, and the cable's really fast and the card's really fast. It's faster than anything you can do on that system. And because you're basically dealing with wavelengths of light, you can run whatever protocol you want on it.
Yeah.
Okay, so that starts feeling simpler. But the thing is there's a consequence to that. And the consequence to that is none of this has to look or feel or be designed the way it's currently designed. You know, you can have a board where, you know, the optical card, like in some designs we have, like in the NSU, optical card is just layered up underneath, right? But if you wanted to, like if you made these boards square, then you could put the port here, or here, or there, or there, or you know, there, if you will. And then the consequence of that is it can be a sled, it can be a blade, it can be top loading, it can sit this way or that way. So now you've been liberated of the idea that it has to go like this, or it has to go like this, or it has to go like that. So we're liberated of that. Now there's a consequence to that. And the consequence to that is then the whole thing this goes into is assuming that a human being is going to walk up and service it. But we want to take human beings out of that. So now if you introduce robotic systems in there, if a robot comes in, we're not going to, why would we make a robot that's got a complex hand and an opposing thumb? That has to go and flip tabs, move something, move a cable, and then move his hand. Why would we program a robot to do that? You just want a robot to come and go, donk, donk.
It's like a dishwasher.
Yeah, you want it to, you like,
dishwashers,
in
the
that.
robot doesn't pick a plate up.
But if you introduce a robot, then that's got consequences. You know?
Yeah.
And then the funny part, because it's a similar thing like what happened with where OCP came from. OCP came from, let's build a really good building called a data center. And then the consequence of that is that traditional equipment doesn't go in that building.
Yeah.
Right? So let's build different equipment. But nobody else is building this equipment. Let's give it away to everybody else to drive the cost down.
Yeah.
It's the same thing. The only reason NEBs exist is because of the building it goes in. Right? And then when you start, thinking about all this, that there's this interplay between the bigger chassis called the data center, or whatever building it's in, and the equipment that's in it. What the building can do, the equipment doesn't have to do.
Yeah.
What the building can't do, the equipment has to do. Right? And it's sort of this realization that in these buildings, the outer wall of the building is the chassis. It's not just the sort of equipment side of things. But now if you sit there and say, well, the robot comes in, well, that's got implications on the building.
Yeah.
But then it's got these other implications too, like take safety requirements, electrical safety requirements. It's for humans to not get shocked. Okay, it's a robot now, right? And then the only reason somebody can get shocked as well is because you're making the chassis out of metal.
Oh no.
Metal, steel. It's a conductive material. So let's make it out of a not conductive material. And then if we make it out of a non-conductive material, then why fabricate it the way we fabricate it?
Yeah.
We pound steel out and do everything else like that. But a lot of non-conductive materials we can 3D print.
Yeah.
So why don't we print it? Why don't we print it on site? You know? So all this electrical stuff sort of falls away. And then you sit there and you say, oh, well, all the typical stuff you do in the data center from a heating and cooling perspective is also assuming a person's going to go in.
Yeah.
But if a person's not going to go in, have the whole place at 50 or 60 degrees Celsius. It's a robot.
Yeah.
Right? So then the whole heating and cooling stuff basically changes.
Yeah.
Or in this case, we designed, like liquid inlets here to sort of show that.
Yeah.
Just have this liquid cooled. And then the environmentals doesn't matter. I mean, if you go and you seal this, stick it outside.
Yeah.
And so, and then when you start thinking as well of fire requirements, like inside a data center, there's a whole fire retardation system and everything else like that. You have to go and eliminate a fire in a room full of electronics. Okay. Now, you have to do that in certain ways, assuming that humans might also be in the room. Like, you can't fill it up with a poisonous gas. It's sort of like that. But if it's only robots in the room,
Yeah, you can do more. Yeah.
then nobody's breathing oxygen. Oxygen is required for fire to exist. Why have oxygen in there?
Yeah.
I mean, the majority of our atmosphere is nitrogen. Why waste oxygen on servers?
Yeah.
It just gets turned into ozone in there. So make the whole place nitrogen-based.
Yeah.
And then if it's nitrogen-based, well, the fun thing is, liquid nitrogen is negative 275 degrees Celsius.
Yeah, might be a little bit cold, but
No, but the thing is you literally, if you think about it, you just have liquid nitrogen tanks. And then it comes in, and now it's basically like 5 degrees Celsius gas
yeah.
that a human can't breathe, but a robot doesn't care.
Yeah.
And then when you introduce robotic handling of these sort of things as well, then it's like a given footprint can be physically reconfigured to whatever at any sort of point in time.
Yeah.
And when you eliminate so much of this stuff, you get down to the component. And so much of this, when you look at that form factor of things, is about eliminating all the crap that's in between the chip, right, and the person. And then the person becomes a robot, and then it's sitting there and saying that we can make our lives simpler by eliminating all these other sort of things and like that. Now, when you look at the adoption of this, in reality is you may have something like the wall.
Yeah.
You may have something like Open Compute. You may have something like BSP. You may have something like the current HDS.
Yeah.
You might have 3 different generations of HDS. You might have a ruggedized box sitting outside. Now again, the irony is they all have the same chip in them, and they all have the same drives in them, but
Yeah.
they don't all have the same software in them.
Mm.
So then the software-defined story is like, okay, well now that things are simpler, now that there's less interconnects, now that all protocols go, then why is it that in the case of IP as a networking protocol, SAS as a storage protocol, PCIe as a network and storage protocol, and a bunch of all these other protocols, they're all going over the same wire.
Yeah.
Why aren't we all just controlling them in the same way?
Mm-hmm.
Why have separate controllers for separate protocols? Right? Why have a controller as some other thing when we can bake it inside as a fabric?
Yeah.
And so the thing is when you look at that is the key to be able to do these physical changes into things, the key of adopting robotics and everything else like that is a software platform and the software-defined aspects and so on like that. The idea of whether it's the wall, BSP, HDS, the OCP, same network fabric, same software abstractions for resources, same sort of way of deploying on, same sort of understanding of what the capabilities are. That the software is like a prerequisite to do that in there, you know. And so I think, so one thing we sort of want to sort of bridge and do is we have some consistency on components now, right, the physical part.
Yeah, so we've abstracted.
And what we always do in physical parts is we bring it up to like a logical abstraction.
Yeah.
But when you look at network equipment, compute equipment, storage equipment, data environments, distributed across different things, we don't have a common view of that in software. We don't have a common logical abstraction. Once we have that common logical abstraction, that software-defined infrastructure, and that component-based view of the world, then we can finally change all the shit that's in the middle there to make it good. That's when that's when we're free of lock-in. That's where we're not doing full rip and replace. That's when we're sort of sitting there and moving the whole infrastructure forward and getting it optimal. That's sort of required. And so I think what we have to be very careful of is BSP is not coming to HDS, and OCP is not a bastardized cousin of HDS, and someday it's going to be the wall in that. We have to sort of do is Intel chip, Intel chip, Intel chip, Intel chip, ARM SoC, ARM SoC, ARM SoC, ARM SoC, memory, 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 right? Software that brings that up to you. That now you're actually staring at CPU capabilities and memory and sort of this, and you're staring at fundamental component resources. And we have to stop taking the human eye and getting obsessed with mechanical form factor. That it's the liberation of that that allows us to start doing some really interesting things.
Yeah, okay. So, what's the challenge in getting from where we are today, where we started that with HDS and doing disaggregation and SDI, to something like this as a concept in the future, or do you think we would ever end up on anything that will look like this? Or
Well, so one challenge is usually in any company, the networking team is not the application team, it's not the storage team, it's not the data analytics team, it's not the security team, it's not the facility team. These are all different teams. And so, you know, so one of the things is, as you can imagine, it's tough enough to come in with software for just the networking guys. Now you actually have to come in with software that the networking and the storage and the application and the security, all these guys are happy. And not just happy that they start, like that experience we put in front of them is the experience they all coalesce around in that. They all feel like they can get their current job done, but they can develop a plan for the future. You know, so it's one of these things where, you know, we're talking about like a software experience that's going against different stakeholders. That's always hard. It's always hard. I mean, it's hard if you're sitting there and talking about a business user versus a consumer. It's hard if you're talking about a CFO versus a system administrator. It's hard. and it's also hard when you're trying to take people from vertically integrated silos that got physical understanding sort of all the way up and all those other sort of operational things to then that view, that view, that view. And it's all common. But that's the transformation that people have to make in that, right?
Okay.
You know, and the irony is that they often internally have a hard time doing it, but then they basically say, oh, but we'll just put a team over here and the team will put everything on Amazon.
Mm.
Right? They've done it that way. Right. You know, but it is that getting everybody to agree on what that common experience is that allows them to do their current job and get better at it and change for the future. You know, the reality is if you sit down and say, I mean, look how much work it is just to deal with a bunch of people's network requirements. Now you got to deal with all their storage requirements and all their application requirements and all their operational requirements and all their economic requirements and all their security requirements too.
Yeah.
And we can't have that amplify up. You know, the other challenge is convincing people that making things simpler is the way to go, because we as humans tend to be hoardy little pack rats that make things more complex, not people that let things go that make things simpler. Simple, functional elegance is usually the sign of a craftsman in human beings, not an average person.
Yeah.
Right.
Oh,
Yeah, so the thing is like this type of work goes against human psychology.
Yeah. Okay. And if one of the things that we've spent a lot of time talking about in some of the materials there at the moment is the whole distributed cloud story. So, I mean, my take on that is that this will allow us then to, as I said, once you decide to treat these things as just, it's just an x86 chip and don't worry too much about the form factor that's currently shipped in. So that pretty much what we're saying is that you'll be able to take this same approach all the way down to the computing part that's running in your car, to what's on the street, to what's at the metro level, to...
Yeah, I mean, if you look at a data-centric, data-intensive environment is you know, particularly is inherently distributed. And see, one of the things that we too often say, are we building storage, or are we building compute, or are we building a network?
Yeah.
And it's one of these funny things where if you're building a data environment that has compute and networking as features, then the data-centric approach is a superset of all of that.
Yeah.
The network is a subset. They're not one or the other,
Yeah.
right? Similar thing where if you're building a very centralized system like a mainframe, or a decentralized system where you have servers and storage and networking, or a distributed system, it's not centralized or decentralized or distributed. Distributed is the superset.
Yeah.
Decentralized is the type. Centralized is the type. I mean, all you have to do is if you draw a bunch of, dots on a board, and you basically make all the dots go to one dot, you're centralized. If you make a couple hubs and you do a hub and spoke, you're decentralized. If you connect every dot to every dot, you're distributed. And in fact, what people sort of forget is there's a whole bunch of dots, and then how we connect them is the question, right? And if we connect them in a totally mesh way, is it fast enough?
Yeah.
And we have to get out of this idea that, and far too often, and it's one of these things, like network equipment can't be compute and it can't be storage when it's optimal. But data equipment can be compute, can be a network. And compute equipment can be a network. Okay, they're just like this.
Yeah.
But it's a well-distributed system can function in a decentralized or a centralized way just based on desires and policy.
Yeah.
But far too often we build distributed systems that can't.
Yeah.
So it's one of these things where you can go one way but you can't go the other. And then far too often people are out there building distributed systems that are shitty and they aren't.
Yeah.
And it's one of these things, like if you look at the classic stuff of somebody like Michael Stonebreaker, who was a MIT professor and has done a lot of startups and stuff. Michael Stonebreaker wrote this paper in the 80s just talking about shared memory versus shared nothing versus shared disk. You hear these things. So the infrastructure, they share nothing. or one, they share all the memory, or the other one, they share a bunch of disk.
Mhm.
Okay, that's another way to think about it, actually. I mean, this whole everyone's in the same memory thing. Everyone shares nothing, or everyone shares the same sort of bit. The idea that I have a server and I buy storage is a shared disk thing. The majority of people is shared disk. Now the funny part is when you look at the characteristics of shared nothing, shared memory, shared disk, there are things that shared memory is best at. There's a larger collection of things that shared nothing is best at. Shared disk is best at nothing. Right? So if you scale on a scale of 1 to 3, it's all 2s, essentially. Right? The other guys are a combination of 1s and 3s.
Yeah.
Shared disk is what everybody does.
Yeah.
So what we have is we have this type of thing where like the average infrastructure has taken on the average architecture,
Yeah.
and it's good at nothing. Right? And when you look at the things that shared nothing is good at, it's like, yeah, everything should be shared nothing. But shared nothing systems are the hardest to make and the hardest to make fast.
Yeah.
They're non-trivial to do.
Yeah.
Right. And that's true of a lot of stuff. I mean, a lot of stuff that's like the best. I mean, if you want to be the best runner in the world, it's non-trivial. You want to be the best weightlifter in the world, it's non-trivial. You want to be the best fighter at the world, it's non-trivial.
Yeah.
You want to be the best at something, it's non-trivial to do. And the reality is that shared nothing systems are non-trivial. Operating them, another is non-trivial.
Yeah.
You know, you know, it's one of these things where you have, and I don't want to say this to be condescending in the way, but it has one of these things where people sit on the couch and they watch the Olympics, and in their head they're like, I could be in the Olympics. I mean, every Olympian starts with, I could be in the Olympics, but they're not an Olympian.
A million people start with that.
And for every person that's at the Olympics, there's probably 100,000 people that aren't at the Olympics.
Yeah.
But every single one of them at one point was sitting on the fucking couch watching the Olympics, deciding they're going to be an Olympian.
Yeah.
Yeah.
You know, and you have these types of things where people sit around, they're like, oh, you know, we're going to be like James Hamilton's team at Amazon. Okay, well, that's not trivial. And that team's been cranking away at stuff for a decade. And they have certain operational pressures that allows a certain type of decision making and everything else. If you don't have those pressures, and you don't have this, and you don't have this, and you haven't been doing that, you know the experience, you're signing up for a non-trivial thing to do. And that's a little bit of the issue. And so, you know, we bump up into just the wet computer we have in our head.
Yeah.
Like there's this great study that was done of monkeys. So you take a bunch of monkeys and you put a ladder up and you put a banana on one of the ladders. And inevitably one of the monkeys climbs up the ladder to get the banana. And the second that monkey touches that banana, all the other monkeys get sprayed with water. And they do that over and over and over and over and over again. Until what happens is all those monkeys, well, once a monkey starts going up the ladder, all the other monkeys gang up and beat up that monkey. And then you take an old monkey out, you put a new monkey in. And you take an old one out, you put a new monkey in. You take an old one out, you put a new monkey in. You take an old one out. Till eventually you've replaced all the monkeys. And no monkey has ever been sprayed with water. No monkey's ever experienced that. Every new monkey that comes in climbs the ladder and gets the shit beat out of them. By a group of monkeys
We don't know why they do
that
it.
have never experienced the negative effect.
Yeah, because that's what they always did. Yeah.
Right? That's what monkeys do.
Yeah, humans do it
And
too.
when we do the same thing, then that's the little lizard brain with the little primate brain sitting there, and that thin veneer of humanity, where we're supposed to be not the monkey,
Yeah.
when loses out to the monkey brain.
Yeah. Oh, when I worked for P&G, they told me in one of the factories in the laundry factories in London, you shut down for a week every year to clean baffles in one of the chimneys. And somebody asked, why do we clean these baffles? Why are the baffles there? They were for heat dissipation during the Second World War to stop German bombers from tracking the factory as used as a waypoint on the way to London. No one had ever taken them out. Okay.
Why is a powerful question. It honestly is. And you can sort of, I mean, you walk into a data center and you're like, why are the floors like this? So it's like, okay, well, why is that like that? Well, why is that like that? Well, why is that like that? Okay, so what if we did this? I mean, like hypothetically, what if we're sitting around in 2025 and 5G was 100 gig? And why wouldn't a data center be wireless?
Yeah. I think there are a couple of reasons, but anyway. Yeah.
No, but why not?
Yeah.
You're staring at 2,000 devices in a data center.
Yeah.
That's more than 100 million subscribers on a 5G network.
Yeah.
There's only a couple thousand fucking devices that you have to control and collect data from.
Yeah, it was easier for someone outside themselves to interfere with the operation internally if you're doing it wirelessly, whereas it's wireless.
It's the whole thing in a Faraday cage and you're done.
Yeah.
Very cost effective.
No, build, I mean, you just make the outside of the building, you just impregnate all the walls with copper, you just build a Faraday cage, and inside the Faraday cage, you can run a full mobile network
Yeah.
that has no interference from the outside. Yeah, okay, so we just put everything in a copper cage and you're done. I mean, it's, you know, I mean, it's a,
Yeah. And it'll cook your lunch for you as well when you bring it in there. Okay. Last family of
I
questions.
will make a wireless data center, by the way.
You will?
We'll bring that next year.
I wanted to do it this year, but,
Yeah.
no, because I want the equipment management network that Command Center talks over, that does the control of data collection.
Yeah.
That's a 1 gig network.
Yeah. Because I mean, even again, it's the implications thing. We're physically shifting objects
Yeah, so
around
next-
because we
so-
want them to connect to wires, but do they need to?
Yeah, so in the next 2 years, I think that network should be a 5G network.
Yeah.
I think we should manage a motherboard and a component on a motherboard no different than we do a smartphone.
Yeah.
Because that network never needs to be more than 1 or 10 gig.
Yeah.
Never more than one.
1 gig, 10 gig, yeah.
So, I mean, the last one is, I mean.
And by the way, a bunch of the activity that goes on is signaling.
Mm.
You know, and so it's like, yeah, so if you're sitting there and thinking like, oh, well, you know, signaling is control. And so if you're sitting there and saying, well, we need to scale signaling, we actually know how to scale signaling. So you literally start sitting there and having diameter signaling as the way that you're actually scaling out a control system for a wireless control plane for a data center. That'd be a piece of fucking cake. You also, if you basically, I mean, 4G and 5G doesn't have GPS-based timing, but you know, you can triangulate it inside and get plus or minus 4 nanosecond timing precision on these boxes too. Great, wonderful. We got a great internal clock. Get rid of a bunch of the additional equipment, use other assets, blah, blah, blah. It's like, but the thing is like, for some reason, you sort of walk in there, and people are like, oh, you know, I hate this box and these fucking cables and all these fucking cables. And you're like, why are the cables? How do you get rid of the cables?
Yeah.
You know, it's like, oh, we can't get rid of the cables for 2 years. Okay, but it takes us 2 years to do anything, so why don't we start getting rid of the cables right now?
Yeah. So number one cable, that's the power one. Even that gives you time.
Yeah, but it's funny because it's one of these ones where it's like, it's not like, Mozart didn't become Mozart at the age of 20, he became Mozart at the age of 4. Gauss didn't become Gauss at the age of 20, he became Gauss at the age of 4. And I'm pretty convinced it's because they thought like a child all their life.
Yeah.
Kids were always asking them why. Eventually, at some point when you go through your education, what's entirely beaten out of you is why. And this whole like obligation to ask why and potentially even dissent and say, well, maybe this isn't the best thing, maybe we shouldn't be doing this. That gets beaten the fuck out of you. And if you look at like all the problems we basically have as adults, is nobody stops and says, why? You know?
So sometimes you do meet inquisitive idiots. So
Yeah,
not all
well,
whys
I
are
mean,
good, but yeah,
yeah.
I totally accept where you're coming from as well, yeah.
I mean, yeah, you're talking about people that when you answer why, they don't get it, they don't remember it, and they ask why again, but that's something else, man.
Yeah.
That's something else.
Yeah. So, we'll just finish up, I mean,
It's also one of the problems too, by the way, that like, the smarter and smarter you get at making a product, the less and less fitting it is for the average stupid person.
Yeah, They don't understand what to do with it, yeah.
You know?
Yeah.
And then if you're sitting there and doing a thing where you're going and selling to somebody, where you're like, well, you know, with our technology, you don't have to exist. That's a tough sell.
Yeah, you need to package that one a little bit differently. Yeah.
So, yeah, but you look at things where but you look at things where it's like, take what we do from a managed services perspective.
Mm.
Why would you ever go talk to the CTO about that?
Yeah.
Because you go to the CTO, it's like,
Where's
particularly if
my
they
job?
didn't initiate the conversation. If they initiate the conversation and said, well, you know, I'm trying to eliminate my job and my team.
Mm.
You know, can you guys take it over? What would that take?
Yeah.
Okay, that happens every now and then.
Mhm.
But it happens because it's a brand new CTO who's
Doesn't really.
not really technical, doesn't give a fuck.
Mm.
And he may even work for the CFO. I mean, you know what I mean? It's like,
Position.
Yeah.
but it's, you know, that's always one of these funny things.
Yeah.
But going back to that, I think the importance on this is, because my concern about the wall is people are gonna see the wall, and they're gonna think the wall,
Mhm.
and they're gonna say, I want the wall.
Mhm.
And it's like, well, but Intel chip, Intel chip, Intel chip, Intel chip, where the fuck would you put the wall?
Yeah.
You know, and it's like, you know, and it's not, you know, and we have to, it's one of these, either balance, you can either call it balancing acts or ironic situation or paradoxical situation where we're trying to show this hardware diversity to liberate the mind of form factor
Yeah.
in some way,
Exactly.
Yeah.
you know. And by sitting there, if people see the wall and they're like, oh, yeah, then they may desire it. But it's one of these things where if you all of a sudden desire this, then you're less likely to fuck your wife, maybe. You know, you know what I mean? It's like desire to let go of that, to bring the conversation up to something else.
Yeah.
So,
Yeah. So, not but sort of related to that is
because
that
there's nothing as bad as, oh my God, you're videotaping.
pretty sure it'll be a private
this
link on
point-
YouTube, but
After this point, we thought about distributing a little bit wider than just to Nate and the mic,
Yeah.
but now
Now you can
I know.
edit the end off.
you come in here some morning and see it on the screen outside. Yeah.
No, I mean, but that's one of the funny things is I realize this where, I mean, I tend to be, you know, at one point I was, you know, highly technically sophisticated, always sort of going down, and this is the best technology, and this is sort of this is sort of that. And he sort of basically realized that, like, oh, okay, well, this is, I mean, I'll never, ever, ever, ever do a CTO or like a VP of engineering job ever again, ever. Because you're always at the mercy of whoever is allocating resources and doing incentive setting. But that's somebody that's more like a general manager or a CFO or something like that. I'd rather just go back to school and get my accounting certification and be a CFO that's highly technical. Because it's like the challenges so often is the sort of, and it's somewhat related when you do these funny things like the, yeah, there was, yeah, no, it wasn't. So there was this woman, Barbara Hershey, that won a Nobel Prize in medicine. She's the one that came up with the genetic basis of why, you know, when you look at corn, some of the kernels are different colors. That was literally what she studied, right? But this idea that within the same thing you could have that type of mosaicism was like, ooh, you know. It took her 50 years to win that prize. And she was very, oh, thank you, everybody, it's so great. There's this other guy, though, Rouse. They discovered the Rouse sarcoma virus. So he literally took, like, cancer out of chickens, squeezed the shit out of it, filtered it through where not even bacteria, the only thing you can go through was the virus. It was basically small through his filter. Injected another chicken got cancer. And this guy discovered the idea that viruses used to cause cancer. And he did this in, like, 1912 or something like that. He then, and he was, I think he was in his late 20s, he finally won a Nobel Prize at like 92 or something like that. And basically when he found out he won it, he was like, fuck you, fuck you, fuck you, fuck you, and fuck you. Because, you know, like from like 72 years old to 97, everyone's like, oh, Rouse was right. From like 27 to 72, everyone's like, oh, what an idiot. You know, and you have a similar thing where very often as you sort of make a product and you basically show up and you realize you're, you know, it's like making healthy food, but then everybody's basically eating non-healthy food all the time. You're like, oh, you should eat healthy, and it's like, okay, you know, it's always funny. But then the play on this always is how to do something that moves the ball forward, but it's very easy to be consumed by anybody, and even more than consumed, like they crave it.
Yeah.
They crave it.
To that tipping point where they have to have it. Then, yeah.
Yeah. I mean, it's like this thing I tell myself all the time that good ice cream's really healthy for you. Good combination of fat and protein.
It makes you feel good, releases endorphins. Yeah. So, last one. Why not? What's the challenge somebody could put to this idea?
Well, a challenge would be everything's fine. No need to change.
Again, where we're going with what we've got today.
Yeah, which is you know, because if you think of this, if you think of two things, first one, cost of something.
Yeah.
In particular, like the unit economics of it. You know, meaning like this would be a unit and this cost, you know, $100 to make.
Yeah.
Right. This unit, and a unit could be a virtual machine or a gigabyte of storage or you know, gigabyte of traffic or whatever you want. But the unit economic cost of something, and then the application and data that you have, where you either have more of an app, like an app's got to scale out to be more of an app, or you have more apps and more data, like you have a greater diversity of it. You know, so you either get fatter or you have more of you, but you weigh the same. Right. So if you logically think about that, unit economic costs can go up or down. And then the sort of application, data, diversity, or scale can go up or down. And then anytime you basically decide that you're going to draw a mathematical relationship, and you decide you're going to smooth out a line, you know, the line can go from linear and then this gets more and more curved to have an exponential relationship. So you make linear exponential. So then you're like basically exponential plus linear plus exponential minus linear minus exponential plus linear plus exponential like that. If you rate that out, you get 16 possibilities. You can graph 16 things. Okay. Now, some situations are awful, like cost goes up exponentially and capabilities go down exponentially.
Yeah. Not many go that route.
Hopefully not.
Yeah.
Or a lot of technologies, in order for you to go up exponentially and stuff, the cost goes up exponentially. Or in some things you're going linear and the cost goes up exponentially, you know, towards the end. Some people are in those states. But if you think about what's the definition of quote unquote hyperscale, it's two of those 16 graphs.
Yeah.
It's a graph where application data is going exponential and cost needs to be linear. Or application data is linear and cost needs to go exponentially down. Right. And when you sit down and you say, if you show up to anything and you say, I need to make it 20 or 30% better, that's different than I need to make it 60% better. That's different than I need to make it 90% better.
Yeah.
When you're talking about making something 90+% better, it's exponential. You're talking about making it 20% better, it's linear.
Incremental. Yeah.
You know, and even that sort of thing where what does it take to be 20% better is different than what it takes to be 60% better. Is different than what it takes to be 90% better.
Yeah.
And we sometimes don't understand that you can think of this as either three phases or stages or whatever. there are plenty of things where you basically walk in, and if you think of that, if you think of those 1, 2, 3s, it relates somewhat to when people are talking about a system of record. It's not like the number of employees at Ericsson, the employee registry is not exponentially growing.
No.
And the cost of it may be not a big deal, right? Okay, so leave it alone. So there's some people where you go and you talk to people and you realize that they don't have a problem. So what are you trying to do? Or what they're dealing with is a bit of it's fine how it is, and there's some technical debt in there. And then you're sitting there paying the debt off, meaning you're running it, and you're just sort of keeping it going. And if at some point the cost of technical debt is greater than the cost of replacing that, then you should replace it. If the cost of just paying off the technical debt is less than replacing it, you should call it a legacy system.
Yeah.
A lot of people don't have a very structured definition of that, by the way. Well, you know, and so a lot of times it's one of these ones where, you know, you're talking to a group of people that just fundamentally don't have the problem.
Yeah. Which one wants to do?
And then when you look at this over a period of time, like if we go back to like 1995, you know, or I saw these great things of if you went and made a slide that said what industries were impacted by the internet to date, okay, you would say retail was, you would say media was, you would say telecom was, and that's it. Advertising, you'd say advertising, which is a subset of media actually.
Yeah.
But media, telecom, and retail. That's who that. But the funny part is when you look at the 5G slides that we show, though, which other industry?
Transport, hospitality.
No, but that's
If you look at Uber, Airbnb,
that's
two
the
good
internet.
examples.
The internet.
Yeah, but they effectively have disrupted those industries. You can't sit
No,
there as a
no.
hotel owner and say you haven't been impacted by the internet.
Not yet, though. That's new. I said go back to 1999.
Okay.
If you look at that sort of 1999, 2009 type period of time, the only industries that were being impacted by technology was retail, media,
Yeah. So one thing the channel
and telecom.
was now shifting to the internet. Yeah.
Yeah, like we had, people actually had to start rolling out broadband, we had to start having data services, we had to sort of do fiber. There's a massive build out of broadband.
Yeah.
So telecom was affected by that. Retail was affected by that. Media was entirely disrupted. And in particular, a subset of media advertising was really revolutionized by people like Google and stuff like that. But that's it. That's, you know, the 1999, 2009 sort of period of time. Now when we start sitting around talking about now, then the things you see is transportation gets affected, manufacturing gets affected.
Yeah.
The list of industries that you sit down and say, what's 5G going to touch? We tend to sort of sit down and say, well, you know, yeah, it's going to touch retail, but that disruptions, retail's already dealing with that sort of stuff. Retail's already sat around and came up with RFID tags on things, and this and this, and how we're doing this, and everything else sort of like that. I mean, it is true somewhat in the sense of technology was a big enabler in logistics. I mean, when you start looking at shipping and logistics, in that, FedEx and those sorts of things. But none of that required the internet.
No.
You know, FedEx could come in and disrupt shipping and logistics just with an internal system designed a certain way.
Tracking and packaging the internet.
You know, but this whole like infrastructure that we're all using, if you will, retail, media, and this. Now we're talking about building out this whole other infrastructure, and we're talking about this whole list of industries. And I was just looking at a 5G, the Mobile World Congress 5G slide, and it has, you know, industry. And I look and I go, media's not there, retail's not there. Telecom's not there, because what's been going on from a technology perspective has already been impacting those three. These are newly impacted, right? But if you think about that, if you go to like any government, Ministry of Labor, Ministry of Economics, Bureau of Labor, whatever, they say, here's the list of industries. And so far, this many industries have been impacted by technology. And now we're saying going forward, it's the whole list.
Yeah.
And, so much of both media and retail and this sort of stuff, so much of where a bunch of value creation happened was in disrupting advertising, actually, right? And then if you look at the list of the rest, one open hypothesis is that the equivalent of advertising for 5G and IoT are probably going to be insurance. Meaning having the same thing, like having a brokerage model, having an auctioning model, it's going to be insurance.
Yeah.
That's in the middle of all this stuff. That probably going forward, insurance will be the equivalent of advertising and how that happens. And you have more industries doing that. So you have more of these industries give a shit about technology. That wasn't the case 10 years ago. And so, it's not surprising that when you sit around, it's like, yeah, Google's advertising and Facebook's advertising, Amazon's retail, Walmart's retail. I mean, it's like you start going through all the giants on stuff.
Yeah.
And it's sort of like what they do. There's platform players like these guys.
Yeah.
But tend sort of like not to be. And so I think more people are impacted by this, and so one hypothesis around this is like, okay, if you don't ask yourself, am I appropriately using technology and therefore infrastructure and everything else to do something more in my industry? Then it's sort of an open question as to whether you're going to live or die, succeed or fail, or go broad versus being jammed into a niche like that. I mean, if you're Jiro and you make sushi, you don't need technology.
Yeah.
You need niche craftsmanship.
Yeah.
If you're somebody that makes one dining room table a month and you sell it for $25,000 at auction, you don't need technology. You need craftsmanship.
Yeah.
So there may be some companies that become craftier.
Yeah.
And in fact, that's okay for them.
Okay.
But then other technology, I think other companies are going to have to they're going to be on one side or the other of that. But if I was sitting there, on a board or you come in as a CEO, I mean, the first question I'd sort of ask is, are we craftsmen or not?
Yeah.
Or do we just happen to be in a business where, we can have some degree of automation and some degree of this and some degree of that. But if we let the craftsmanship go, then everyone disappears. Because they expect
How are we
that.
any different than anyone else?
It's the same type of thing. I mean, you can think of like IKEA in the furniture space. I mean, they've done a lot of innovations on packaging and sort of how you put it together and how you manufacture it and everything else. But over the years, they've made nicer and nicer stuff, right? And you have to argue that if they didn't do that, then the other stuff wouldn't have happened, and that sort of thing. But I think IKEA is sort of a good example of ones where it's like, oh well, the craftsmanship has got to stay there, and we'll do some operational things to sort of make it better. But there are a whole bunch of companies where it doesn't quite, the craftsmanship doesn't quite matter. And then for that, it's like they're sitting with this really funny fact. And that is that when you look at like Global 2000 companies, I mean the probability they'll still be exactly the same corporate structure 5 years from now is currently like 30-something%. So like if you look at companies if you go 5 years back and then you look today, 33% of those companies still around. the other ones have been acquired, or they merge into something, they sort of this, or they go out of business, they sort of do something like that. So we have so much more turnover in a 5 and 10 year period of time than we basically realized. And I think that's one of these things. So I think there's gonna be people that you come to with this story who are either gonna be in that, look, we're just trying to make it 20 or 30% better, not 90+% better.
They feel it's an answer to a problem
And
they
there's
don't
a
have.
certain degree of like customer contact and craftsmanship and expectations around this where technology can augment, but it's not the point. And, you know, where we have to be okay at that, you know, or, you know, we have something where, you know, the business is so sufficiently profitable and everything else like that, that what we spend in technology is small. I mean, when you head up to high-frequency traders that may spit out a couple billion a year in revenue, but they're doing that on $50 million of infrastructure, what do they care if it's 50 or 80 or 40 or what? They don't care. I mean, they'll sit down and say, oh, I'll try this and I'll try this and I'll try this, because the cost of it is so small.
Yeah.
You know, if you're in the pharmaceutical industry and you're buying, you know, $100 million of something, but it's to support a $6 billion drug, you don't care. You don't care. You know, so, yeah, that's.
So other than those who don't feel they don't need any other particular challenges to going this route? Or without necessarily getting into... Yeah,
No, I mean, I think again, it's one of these ones where companies don't innovate, people do.
Yeah.
And companies don't sell, people sell. And
Yeah.
companies don't buy, people buy. And I think every cloud transformation that I've seen gone wrong, you know, over the last decade of doing them, is people.
Yeah.
And the way that you structure them and how you incentivize them and what they're excited by and what they feel threatened by and sort of everything else like that. You know, when I've like when I first came here, I remember going to a customer meeting almost right away, and it was the operational and technology team standing there saying, well, you know, our CEO says that we have to take 60% of OpEx out. And there were like 20 of them in the room, and I jokingly said, okay, so when we meet in 2 years, there's only be 8 of you.
Yeah, you're actually talking to you right there.
And I remember they were like, well, what do you mean? I said, you're the OpEx. You know, so can we have a quick conversation right now about just how rapidly are you going to be moving into this type of transformation being done by you guys, when it's going to be a Lord of the Flies type scenario? That literally for your organizations to take 60% of OpEx out, he said there's like a total of like 3,000 of you. 1,800 of you won't be here when you've saved 60% OpEx because you're OpEx. You know? I mean, it's a little, because in a lot of ways it's like somebody showing up and saying, I want to eat your family, but you're going to kill and butcher them.
Yeah. Okay, we got to think on that one on.
No, but I mean, it's a
Well,
very
most of the
extreme
week.
example, but you're sort of sitting
Yeah,
there and
well,
saying,
that's-
oh,
yeah.
you know what? I want you and your team to get super excited
Yeah.
about that. Now, the funny thing is how do you get people excited about that? You know, you literally have to come in as like a CEO, CFO type sort of person and say, okay, I'll tell you what, guys. You know, here's what we're going to do. I need to save this, and I need you guys to save that, and that means that your jobs are going to go away. But I'm going to view the savings over 5 years, and I'm going to give you guys the first 18 months of savings. So if you do this, as soon as you do this, I'm going to put $1 million in each one of your pockets.
Yeah.
Right? So like if you got 1,000 people you need to get rid of, I'm going to give you $1 billion. I'll give you the first year savings to bonus those people. And I'll let you do the bonus anywhere between $100,000 and $10 million. Right? Now, if somebody actually sat down and said that, what would you do? You'd fucking kill yourself to do that transformation.
Yeah.
You'd be sitting there as somebody running 200 people, and you'd be, okay, at the very bottom, these guys are I'm gonna put 200 grand in their pocket, and sort of this, my team's gonna get 2 million each, I'm gonna put 6 million in the bank for me, we're all gonna kill ourselves to sort of do that. And then if you do something fun too, like you sit down and say, okay, well now that we've structured that tree out, we're also gonna let everybody horse trade up to half. So like 4 people go to one person and say, look, I'll give you half of what I got coming if you really stop being a dick about that. Right? But nobody does that.
No, because if they do it, it's actually only goes to the...
I mean, we did this, like, if you look at Ericsson's voluntary program, there's a little bit of that. It will give you like 2 years of your salary if you just, you know, like, help us out a bit. Right? But if you imagine these types of transformations, if you sort of sat down and said, we'll give you guys the first year savings as a bonus. We'll extend it sort of a year out on that. But we need you to drive it. And so the thing is we don't, you know, far too often people, they don't think like, who is actually going to do this? What people? Do we have enough of the right people? And how are they going to show up every day? Super fucking excited, sort of go and do that. And it's a similar thing, like when I've done startups and you start like hiring your first dozen sales guys or so, the thing I'd always do those first dozen sales guys is I'd sit down and be like, well, you know, like, look, so we have sort of 2 options. You know, one option is we pay you guys a higher base salary, you know, but then, you know, you can maybe double it with commission. If you're willing to go no base salary, you're willing to be free for the first year, like that, for example, everything's uncapped. I'll give you 10 points of whatever you sell uncapped. You can close a $50 million deal, you make $5 million this year. But if I gotta pay you 200 grand and you go sell a $50 million deal, I'm gonna give you 200 grand in commission. What do you guys wanna do? The funny part is a lot of times, like, somebody's gonna say, like, I'll go 0 base. Oracle did that, Sun did that, everything else. And then you start looking down, it's like every like sales guy's driving a Ferrari, great. And then like one thing that Oracle always did that was very smart was they let the sales guys, they basically sat down and said, we really want to drive this role uncapped, but you can also basically allocate it out to other people. So those guys would pop into like engineering and be like, wow, I really need this and 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 this. And then look, then you sit around and it's like 200 grand goes to an engineer, 200 grand goes to an engineer, 200 grand goes to an engineer, 200 grand goes to an engineer. And the sales guy takes 1.2 million on that. And then he rinses and repeats 4 times that year, and they're done. You know, I mean, everyone's happy. You know, and you know who's like really good at this, by the way, is Huawei.
Yeah.
Huawei does this. Huawei's whole profit sharing scheme they do and sort of everything else like that, how they sort of do things, is one of these ones where it's like, you know, and it's we have this sort of idea that, well, they must be giving everything away, they must not be this, they must not be that, they must be that. No, everyone's there is like incentivized to like close shit and have it be profitable and split profits. People sit around and doing profit math all the time. And then when they sit around, then what that actually incentivizes everyone to do is really be focused on cost. So they do find cheaper people, they do find this, and they do it with less people, they do it like that. They focus on manufacturability, they focus on cost of manufacturing, I mean,
Yeah.
you know what I mean? And so the usual sort of issue is always the issue. It's people and the psychology of people and how you're allocating resources and how you're incentivizing them and whether everybody is excited about this mission, whether they love being on the team that they're on, whether they're being like financially and otherwise recognized for basically doing it, where they feel super driven, right? I mean, it's a similar thing where if you sat around where, you know, if the CEO at Ericsson came in and said, you know what, guys, is we're gonna set aside 12% of the cloud top line, and we're basically gonna do this, and depending on sort of how you're this and that, it's all gonna get divided up for you guys. What would everybody do here?
Work it out.
Work like hell. I mean, if you did a little bit of simple math and you're like, whoa, if we fucking kill ourselves for the next 3 years, I put $2 million in the bank. Cash? Yeah. I'm gonna fucking kill myself.
Have you proposed it to?
But you understand what I mean, it's one,
Oh, yeah.
it's one of these ones where, and instead, the alternative usually is, you're just watching it wasted, basically, everywhere,
Yeah.
and you're sort of doing this, and you're basically
Can't
incentivized.
get urgency because those around you aren't.
Yeah, good, and it's funny because, you know, like, some stuff I did at Joint, for example, was like, not cap the sales guys.
Mhm.
Let the sales guys bonus other people.
Mhm.
Yeah, that always works exceptionally well.
Mhm.
Whenever somebody said they needed a new head count,
Mhm.
I asked them how much the head count was gonna cost. And then the first thing I did is I said, well, here's what I'm gonna do, okay? I'm gonna add that to your salary. And then if you hire a new head count, it's gonna come out of your salary. And we'll do that for the next year, okay? Right, and the funny part is, like, when people would hire the other person, then I'd be like, okay, they're really overworked. No, but you meant it. If you went to, like, you know, your boss here and said, well, you know, I really need this, and I really need this, and I really need that. They said, well, you know, why don't we hire one person? You know, but what I'm gonna do is I'm gonna add the other two people to your salary. And then maybe you can incentivize the other person with sort of whatever you want. Let's see if you really need three people. And then the person literally goes, wow, I really need three people.
Then you know.
Then you know.
Yeah.
But you know what's even worse, though, is taking somebody that's half productive and having them hire somebody else that's new, and then encouraging half productivity across people. That's actually more expensive.
Yeah.
Understanding that person there can't turn the dial up is more expensive.
Yeah.
You know,
Okay.
but it's very hard to do in a larger company where you
Mm.
know you have HR things. And
Yeah.
how am I going to pay taxes on this? And this means I have to pay higher social fees as well.
Yeah, the models are different. Okay, sir. Thank you for your time. We will.
Yeah, I blew off a whole other meeting, but whatever.
Yeah.
I was supposed to give an update about cloud to the regions.
Yeah, I met the channel guys this morning. They do seem to be a bit concerned. They don't quite know what we're selling to who and why. So.
Well, if they can't figure that out, they should quit their fucking jobs, and maybe the replacements can figure that out.
Yeah. Well, we probably need to do a bit of work on strategy and communicating that with them.
Yeah, sure. Everyone just has to understand they're being hired to be a cook,
Yeah.
not an eater,
Mhm.
a cook. If you can't cook, then you don't eat.
Yeah.
Yeah, I can't come up with everything for fucking everybody. You're a channel guys. Come up with the fucking channel strategy. Tell us what the fuck you want.
Yeah.
Also understand how the fuck we do things and make what you ask reasonable.
Mhm.
You're here to fucking cook,
Yeah.
not eat.
Okay.
Send
that
them the video.
Might need some
But no, but
editing.
But at the same time, they're right. You know, I mean, the funny part